So my name's Adam. I work at a company called Spring Lab in Cape Town. Um, and let's just kick into the first slide and I'll kick out that music before it gets annoying. Well, it's just hard to say. I mean, it's Ennio Morricone. It's kind of hard to get annoyed at, huh? Anyway, before I can't press stop, because otherwise I'll just sit here and you'll be watching me listening to music, which is probably not what you came here for. So as I mentioned, Spring Lab, we're a company based in Cape Town. We're an incubator with a focus on building lean startups. We're a pretty young company. We've only been around for about 2 years. We've been producing code for the last year and 3/4 roughly. And currently our main and primary and essentially solo venture at the moment is a company called Recommend. We're basically a search and booking engine for medical practitioners in South Africa. Now, obviously, assuming all goes well, it could expand beyond South Africa into Africa in general. It could expand beyond medical practitioners into other semi-related areas. But, all that, obviously, in a startup, you can't spend too much time thinking about the distant future because you actually have to, work and, get stuff done today. Because if you don't, you're not going to be in business in 6 months' time. So, as you can guess, given that this is a web-based project, this talk is going to have quite a strong focus on web-based technologies. But I mean, obviously there's some stuff here which applies even if you're not in a web-based context. And as you can see from the slides, our system's built primarily in Python 2, using a bunch of familiar extras. Obviously, some of these things you're probably familiar with, others you might not be as familiar with. At the end, during the questions time, if you want me to tell you a bit about something, just feel free to ask, or just harass me afterwards, or email me, whatever. It's all good. So I'm just going to move on to the startup environment. So I mean, what is it like working at a startup? Well, I think you can't really place a hard, fast thing on this is what it's like. It's going to vary from startup to startup based on the personalities involved, the size of the startup, what kind of time frame you're looking at to actually, get something done successfully or fail. Because I'm sure you've all heard there's essentially a statistic, which is that most startups do fail. So I think working in a startup, you have to realize that you can't rely on the fact that you're going to have a job in a year's time. The only way you can ensure that you have a job in a year's time is to work hard today. But regardless of the startup in general, you're probably going to have a small development team. In our case, we've had 1 to 2 developers over the course of the last year and a half. That's fluctuated. Most of the time it's been 2 developers. For various periods it's been 1 developer, mainly me. But I mean, you might end up in a startup with more people. It really depends on what kind of funding the startup has, how successful it has been to the point in time that you're at, and so forth. Obviously, the really attractive thing about working in a startup environment is you're writing new code rather than maintaining old code. Now, I think we've all worked to some extent, maintaining old code, and it can be a really painful experience depending on the kind of code that you're maintaining, how long ago it was written, what language it was written in. I mean, I have to say I feel really, really bad for those people who have to maintain COBOL programs written 30 years ago, 40 years ago. I hear it pays well, but I'm not sure the pay is kind of worth the mental anguish involved. So you're writing new code, which is always fun. I mean, it's great to work on new stuff. I don't think there's anyone as a developer who doesn't enjoy working on new projects. I mean, you do maintenance, you realize that it's part of the job, but at the same time, you want to be working on new stuff. It's probably why a lot of people get involved in open source projects, because it's something new. It's a big part of being a programmer. And it's a pretty strong part of working in a startup as well, which is cool. The work environment in startup tends to be pretty relaxed, at least in R1. There's not a lot of bureaucracy, not a lot of red tape, not a lot of politics. Now, I've worked in larger companies where that's been an issue, where it hasn't been an issue. Invariably, these things they're happening, regardless of even if you're even in a small company like a startup. Sometimes it happens. But ideally, one of the benefits I've experienced in a startup environment is there's minimal red tape. If you need to get something done, you can get it done. You're not going to have someone saying, please fill out this form in triplicate, specifying why it needs to be done, motivating. You can say, this needs to be done, we're doing it. And then you do it. And hopefully you do it right. That's the ideal. Obviously, may not happen, but we'll get to that. Obviously, the work environment is relaxed, but the results are very important. As I've said a couple of times already, so I won't go on about it too much. You're working in a company which has got a pretty hard, fast timeline to either be successful or fail. So, the results of what you do are really important. You've got to be, working on the right things. You've got to be prioritizing the right tasks. You've got to be, and generally when you're working on a software project, there's going to be a lot of different, different things that you might like to work on. They might all have value, but, you really need to kind of, in a startup where you really are very results oriented, you have to, make sure that you're working on the right stuff, that you're getting it done, in good time. Because it might be nice to spend a lot of time working on some feature which, it's cool. It's a great feature to have. But maybe, it's not that essential to the company succeeding in the long run. It's nice, but it's not essential. And that time that you spend on that nice feature, which is not quite essential, could be, the make or break point. Yeah. So, this context seems, the startup environment seems like the perfect place to use Python. So, why did we at Spring Lab pick Python for our project? And, going forward for any future projects, we're liable to stick to Python based on our current experiences. Well, there are a couple of reasons why you might pick Python. And I think this might be quite relevant to the various people in the crowd who don't use Python on a day-to-day basis. So I thought it was quite interesting when, at the very start of this PyCon, when I think Simon asked how many people here use Python daily, and there was actually about 20% of the crowd don't use Python on a day-to-day basis. Obviously, there might be various different reasons for that. But yeah, these are the reasons we found to be important. Python is really easy to write, and that's pretty important for being productive as an individual. But obviously there's a bit more context to that because, easy to write in what way? Easy to write compared to PHP, Java, what? Well, PHP is easy to write. You can write buckets of PHP really quickly. You can write yourself into a corner with PHP really quickly. Python, on the other hand, it's easy to write, but the language itself lends itself very strongly towards writing better code, especially compared to something like PHP, in my experience. I've worked Java, I've worked PHP, and most recently spent like the last 5 or 6 years working in Python. So PHP, easy to write. In the long run, not so easy to write because you end up spending more of your time working against writing yourself into a corner. Java is, it's kind of easy to write in slow motion. You're gonna write a lot of code. It's going to take a long time. There's going to be a lot of boilerplate. You might get persuaded into using some new interesting library someone sold you on, maybe the Spring framework. Yeah, some people might recognize that name, which will supposedly revolutionize your life, but actually just result in you writing lots and lots of XML instead of lots and lots of Java. Yeah, so I think out of the various languages I've used, Python is it's a happy medium in terms of easy to write. It's easy to write, but it's also got a clean syntax, it's got clean style, it's got good decisions about the language design, which lend itself to writing good code. Easy to read, and that's, in my opinion, really important for working in a team environment. Even if you're in a small environment with only 2 people, you still have to read the other person's code, you still have to understand what they've written. And you still have to read code which isn't even written by people in your team. You have to read code written by people who are writing libraries. You might not think, oh, I'm going to have to read library code. I can just read the documentation. But I think invariably you'll find that you're gonna start using some library at some point where the documentation is just not up to speed. And that's, I mean, it's not a train crash, and it shouldn't be unexpected either, because documentation is hard. I mean, lots of people have spoken about this, and I know from experience of having to write documentation that it's a hard task. As a programmer, you want to spend your time writing code, not writing documentation. But, obviously having an easy-to-read language helps in this regard, because, you can read the code and get a better idea of what's going on. If you've seen some PHP code, which is written by someone from, say, the PHP 4.3 era, you might go, wow, what is this? I don't understand this. You can read some code written in Python 2, and you'll probably still have a pretty good idea of what's going on. It's not like the language has changed radically since Python 2. Even probably Python 1, it'll still be quite familiar. Yeah, I mean, it's a strong feature of Python. The easy to write really feeds into being easy to read. And yeah, it lends itself to the next point, which is being easy to teach. And a language which is easy to write code in, and also to read other people's code in, and which has got a strong, clean design, it's going to lend itself to being taught to other people. And I mean, in our context, this hasn't been a huge thing, because our developers have been Python developers. But you're not always going to have the luxury of maybe hiring someone who's a Python developer. My first Python job was jumping from PHP to Python, and I started a company called St. James Software, which a lot of you will be familiar with. And that was, basically cross-training from one language to another. And my experience personally, and I'm going to guess for other people, has been that like Python is a language which is pretty good for cross-training. It's easy to pick up. Yeah, and the next part, the strong community. Now, Python has a really strong community. There are a lot of different languages out there with, communities. And the strength of that community is actually pretty important, because, unless you're really the 99.99999 percentile, you're not going to necessarily be able to solve every problem yourself. And a strong community basically gives you free brain power for solving problems. You can go to the community, you can ask for advice, you can ask for help, you can get best practices, you can find out where other people have hit the same problem, what they did to solve it, whether it's applicable, so forth. So in the case of Python, I know probably you're all familiar with the common ones. There's Pound Python on IRC, very useful, great place to hang out and talk to people. Stack Overflow, I don't think I think right now Stack Overflow is probably the key place that a lot of people go for help. Very useful area. Interestingly, a website called Quora has also been quite useful in terms of sharing knowledge. And then obviously mailing lists, forums, there's a lot of those around, and they all just contribute to Python having this really strong community, which is great. I've been part of a few other communities, and I'm going to give an example, which is it's maybe a bit unfair, but the Scala community online it's a bit of a divisive place, because there's a lot of really intelligent people there they know their stuff. But at the same time, they do not have a lot of patience for people who don't know their stuff. So trying to sort of get into the Scala community and get help can be like a trial by fire. You might well get firebombed for asking a question. Maybe you won't, maybe you will. My experience has been that's a lot less likely to happen in the Python community. There are people of all different kind of skill levels. It's a much larger community, much more well established. You're going to have a better time working with the Python community. So yeah, obviously this one is I mean everyone knows this one. Batteries included. I actually didn't bother to put a little image in there because I felt that would be overkill. But you know it's important. You know the Python language isn't artificially limited. Well, Guido and the people working on Python, they do have some pretty strong ideas about what Python is, where it should go, etc. But those ideas don't really fall into the category of like we're never going to support this on any level. There are a few cases of that, obviously, but generally, they haven't artificially limited the language in ways that prevent you from using it properly. It's I guess it's tricky to find examples off the top of my head about artificially limited languages because obviously I mean people writing a language don't really want to artificially limit it, but I guess and this is again it's not really an accurate. Again, actually it's a completely inaccurate comparison. But for example, we have Haskell as a purely functional language. And I mean, it's a cool language, and it's got a lot going for it. But at the same time, because they have this very pure functional approach, and they're not really like interested in supporting a non-functional thing, and that's completely understandable. I mean, it's a functional language, and it doesn't necessarily artificially limit the language, but it does provide a bit of a barrier to people trying to pick up that language. They encounter stuff they're not familiar with, and it's a case of, okay, I feel like I don't really know how to go ahead from this point. Obviously there are ways, but it might seem, and again, as I said, it's not really, it's almost invalid comparison to say it's artificially limited, because I mean, it's not artificially limited in the case of Haskell, but it's just kind of a way of thinking about it, I guess. The standard library in Python, really strong. These guys, you get a lot done without having to, revert to external libraries. I know some of you, I think everyone who's been through university has encountered Java. Java, the standard library is well considered to be kind of garbage. There's some basic stuff in there, but if you want to get useful things done, you have to get third-party libraries. And I mean, there are pros and cons to that approach, but I think for the approach of actually being productive in a short space of time without spending, a week evaluating which framework, to use for maybe something really basic, like making requests, websites, and so forth, you're not. The Python doesn't really limit you so much in that regard, because the core library is strong. And obviously, the great appeal of a language which has been around for a while and has a strong community. If the batteries aren't included, they're probably available. There's a huge number of frameworks, toolkits, libraries, code snippets on places like ActiveState, GitHub Gist, etc., which they basically provide you the tools you need to do what you want in Python. The amount of time you need to spend reinventing the wheel in Python is, in my experience, pretty small. If you have a problem, someone else has probably already had that problem. They've probably already thought about how to solve it. They've probably encountered the key issues in solving it, and they've probably dealt with it better than you will be able to in a week, given that you're under a deadline, which most people are. And alternate Python implementations also give you a lot of options. I mean, I think a lot of people don't really think about it, but it's actually quite cool that you have Jython, you have IronPython, and so forth, which are there's a JVM hosted language and a .NET hosted language, and those actually provide you with quite a few cool interoperability possibilities. I mean, there was a talk earlier today about getting Ruby to talk to Python. Now, obviously, in that context, they're using NumPy, so it's a bit of a different context. I don't think you could really use Jython in that context. I'm not aware of NumPy existing on Jython, but I may be completely wrong. But if for some reason, maybe you just wanted to, make Python talk to Ruby, and you didn't need to use NumPy, you could go through a lot of song and dance Or you could just use Jython and JRuby, and they interact with each other really nicely inside the JVM. And obviously in the .NET space, if you wanted to make F# talk to Python, you could use IronPython. So there's a lot of options, and I think it's a lot of people don't take that into account, but it's definitely a pro rather than a con. More options are almost always a good thing. And yeah, PyPy. I'll bring that up a bit later, but yeah. So Python as a language, it's also mature. The language targets, there's 2 of them, but they're stable. Python 2, Python 3, that's not like Python 2.8, which will never exist, as you may have heard. 2.8 will come out and break the language completely in some way you're not used to. Python 3.5 or 3.6 is probably not going to do that either. It's not what Python's about. And it's actually a big deal, which people don't take into account, because again, I'm going to bring up the case of Scala. As much as I like that language, they break a lot of core stuff between releases. So Scala 2.8, 2.9, breaking changes. 2.9 to 2.10, breaking changes. And that leaves people in people are using the language in a tricky position, because if they want to move forward, they have to fix their code, and they may not have the time to, in which case they might just go, okay, we're going to stick on the old thing. And obviously the Python 2-3 divide introduces a whole different problem, but there is light at the end of the tunnel in that regard. Python 2 does have a definite end of life. We've heard it's 2020. And after that, it's going to be Python 3, Python 3, Python 3. I think if you want to use Python 2 at that point, you're going to have to fork it and probably not call it Python. And then obviously Python has known performance characteristics. It's a dynamic language, but so obviously it's not necessarily going to be the fastest language you can use. It's not necessarily going to be the slowest language you can use. But you can definitely do a bit of research and work out quite quickly whether or not your Python is going to be a suitable choice for your problem. Now, obviously with new languages which are changing all the time, breaking changes and so forth, as mentioned, that's not necessarily a given. And it might seem like, cool, I'm going to adopt this awesome new language that some guy came up with at MIT like 3 years ago. But you have no guarantee that language is going to still be around in 5 years' time or be performing as you want it to in 5 years' time. But even though Python is mature, it's still evolving. I mean, we get Python enhancement proposals fairly regularly. I mean, it's not like a literal flood of them, I would imagine. I must admit, I don't personally track Python enhancement proposals strongly. But they come, they go. They get yayed, they get nayed, so forth. There's definitely development happening in Python as a language. It's not a dead language. And I'm going to be cruel and use the example of PHP. If you've paid any attention to PHP over the last years, it is literally collapsing under the weight of its own. You might say the word evolution, but I would use the word mutation, because really it's going in all kinds of directions, and there's really not much thought to it. And it's definitely kind of reaching a point where I think they're having trouble. As anyone who even knows a little bit with PHP, they're having trouble getting PHP 6 out the door, because it's a case of where do we go from here? Yeah, and then obviously again in terms of evolution, Python implementations, I spoke about them earlier, but that's definitely a strong it's a strong area of development in the language. And I think some people might see having multiple implementations of your language as a negative thing. It's divisive, and there is, an aspect of truth to that. But at the same time, I think it tells you a lot about the strength of your language, that, you have people who want to write their own implementation of it with a specific goal. They're not necessarily just happy to, use CPython. They want to use it in a different environment. They want to use it inside a JVM. They want to use it in a .NET environment. There's a desire to use Python, which is really important. It shows you that the language it's alive, it's kicking, it's clawing its way up the evolutionary tree, and even building little struts on it. Right, so I'm going to actually get into the main focus of the talk now, which is our experience, the good parts, the bad parts, the ugly parts. So it's kind of going to be broken down to two kind of sections. In each part, there's going to be general areas, and there's going to be some comments on specific frameworks and tools and so forth. Yeah. So obviously, writing new code in Python means you can use the latest, greatest frameworks, tools, etc. And that's cool. And I mean, you may not have that option if you're in a company with an established project which has been around for 5 years. You don't necessarily get to make that choice. Maybe you'd like to use a new framework, but you do not have the time. You cannot, maybe sell your higher-ups on doing it. You also get to use Python 3 rather than Python 2, if possible. Now, obviously, this is going to seem a little bit funny coming from me, given that our project is running on Python 2. Yeah, all I can say is I didn't have a direct influence at that point in time as to what was used. Maybe in the future we can move to Python 3. I'm hopeful that that's the case because our project runs perfectly on PyPy, which has been one of my key things is keeping it PyPy friendly. And I think it's probably hope for getting into the Python, making it Python 3 compatible. And I think something which I don't know if everyone's familiar with this, but if you're writing code and you need it to be, and you want to target Python 2 and Python 3, there's a really great library out there called 6. 2 times 3 equals 6. And 6 basically helps you write code which will run in Python 2 and Python 3 pretty seamlessly. And if you have any desire to, be good for the Python community, and you want your code to run, on whatever Python people use, look at 6. It's a great toolkit. I mean, I've just noticed from digging into framework code and library code, going, okay, this library is now Python 3 compatible. Oh, they're using 6. Nope, using 6. So yeah, if they're using 6, so should you. And yeah, Python's definitely a productivity booster. You can get working code done quickly. And it's not just going to be completely hacked together code which you're going to throw away. It's going to be code which you can actually make use of. You might at some point need to throw it away, but it's not going to be completely disposable code, which is quite important. Obviously, a nice side effect of that is that prototyping new ideas is a snap. You can literally whip up a quick prototype of something, test it, go, okay, this works, this doesn't work, this works, this doesn't work. Maybe it's a good idea, maybe we just put it on the back burner for now. And also testing third-party integrations is easy as well in the same fashion. Now, this is quite a like I guess in a web environment. Obviously, third-party integrations basically means REST APIs, and Python testing that kind of stuff is really easy. You just open up a sort of a REPL environment, import requests, start flying. Stuff happens. You can work out very quickly whether or not the integration you're interested in is viable. And then, yeah, advanced Python features, they really help improve productivity. Obviously some of these are more advanced than others. First-class functions, I think most people kind of consider old hat now, although who knows. Decorators, context managers, generators, the whole lot. There's a lot of cool stuff Python gives us for writing code which looks cleaner, is easier to understand conceptually, or just behaves in a fashion which makes logical sense. I mean, you can do a lot of the stuff which as you can do decorators without using kind of decorator syntax. You can kind of hack your own context managers in a kind of really ugly way if you want. But why do it in an ugly way when you can do it a way which is easier to read, easier to write, easier for other people to read, It's great that we have a language which actually gives us these features. And yeah, I mean, these kind of features really, they help you get code implemented without a lot of boilerplate and a lot of tedious abstractions. And I think we've all maybe not all, but some of us at some point have seen those incredible Java factory of factories, which produces another factory, which maybe has a factory of interfaces. I don't know, something like that. But yeah, there's a lot of that kind of painful stuff we can avoid in Python thanks to the advanced features which we have in the language. This one, obviously, everyone's going to know. REPL environments, very useful. I think that's been old news since Lisp, really. But it's obviously taking off more. With a lot of other languages kind of developing. And I just discovered today that now Python, there's now iRuby. So obviously these ideas are jumping around, which is awesome. Obviously, there's other ones, BPython, DreamPy, they all have slightly different focuses, but the general aim is to give you a nice environment to work in, which you can use. Debugging tools. I think I'm personally a huge fan of debugging, probably too much so. In fact, I've been accused of being too eager to debug, which is a valid accusation. Sometimes you should look at your code and try to work out what the error is logically, rather than just trying to inspect what's going on the fly and work out from there. But I think it's really great that we have a language which gives us the kind of tools to debug easily. Obviously for simple debugging, PDB is really nice. You can just throw it in there. Obviously a lot of web application frameworks just automatically reload when you change the file anyway, so that makes a quick PDB quite easy. And personally, I find that PyDevD, which is the sort of remote debugging extension, which you find included with a couple of like IDEs now, is actually, it's great for debugging in a slightly different fashion. It's a little bit less direct than PDB, but it also makes certain kinds of inspections a bit simpler. Definitely traversing up and down the call stack becomes simpler. At least, I would imagine, I guess if you're like an old hand at Python PDB, traversing the call stack in PDB is second nature. But maybe if you're like a new developer, you're going to find that using the sort of like graphical call stack, up and down kind of stuff, a lot easier. It's just one of those things, I guess. And yeah, extended debugging is a lot more pleasant. Obviously, your aim is when you're debugging not to, be there so long that you die. But, obviously there's no guarantees. And yeah, source availability in Python, I think it's one of those really cool things that a lot of people don't appreciate. Or maybe they do, who knows. But I think, it's obviously a lot of other languages, you're using Java, you can get the sources for your Java library. They're not hard to get. But the nice thing with Python is that when you get the library, you're getting the source, generally. Unless you're like getting one of those Pike-only kind of things, which is a bit strange. But generally, you're going to get the sources. If you're debugging, you want to step into the sources, you're just going to go there. If you've ever debugged some Java where you don't have the source jar and you try and step into the library and it's like, okay, we don't know what's here. And then you have to sort of go on a, jump around to actually find the source code. We avoid that quite nicely in Python by having the sources available easily. And it's really, as I mentioned earlier, it's really great to just be able to read other people's code because it helps you understand a hell of a lot. There's a lot of stuff which isn't documented, or it's maybe only in the comments for a function. It hasn't made it into the official documentation. There's a lot of stuff that you're only going to pick up if you actually take the time to actually read into the framework you're using. And I'm actually going to mention this again later in a specific context. But yeah, as I mentioned, you combine that with debugging, and it makes it really easy to track your code execution around into code which isn't even yours, while still actually understanding what's going on, which is important. It's one thing to be debugging, but if you've stepped into someone else's code and you have no clue what's going on, makes it a bit tricky. Yeah. Running out of time. That's not cool. Right, so yeah, good. Well, there's plenty of great frameworks. Fabric is awesome for remote execution. Celery is great for asynchronous kind of scheduled tasks. If you're using cron, you could just use Celery beat, and you're going to keep your stuff all in Python, which is great. Request is so awesome. I think it should be part of the standard Python library at this point. If you look into an API library for interfacing with something in Python, you're going to find that it's probably using requests underneath all of its own stuff. Flask is a cool micro framework. I really like that because it's it's minimal in the minimal amount of prescription as to how you're going to do your web application. Our usage of Django, it's been useful primarily because the admin app actually provides a really mature way for the non-developers in your company to actually interface with your data. Obviously, there's a varying degree of wisdom in that, but that's a matter for something else. PyPy, awesome, definitely worth targeting. The performance improvements you can get, they vary, but I've personally had some pretty good experience with some code which is somewhat CPU intensive. It's not like numerical code, just kind of data processing and massaging kind of stuff, which definitely was a lot more pleasant to run using PyPy. And personally, I found that also debugging with PyPy is a lot more pleasant because in general your application is performing faster, so you're spending, and obviously when you start up I think if you've used PyDevD, you'll find that generally your application runs a lot slower with PyDevD in place. But PyPy actually kind of compensates for that quite nicely. So you kind of get back to a point where debugging with PyDevD doesn't make you want to sort of like tear your hair out in terms of old age. Yeah, and obviously, this is divisive. PyCharm / IntelliJ, IDE. Some people hate IDEs. They're like Vim wizards. I get that completely. Vim is awesome. This is why I use the Vim plugin for IntelliJ, because it's like the only good one available for an IDE. But for new developers, an IDE which has code insight is a really great way for them to actually get to grips with the source code in your project, because they can navigate it a lot more easily. It's easy to forget that when you're familiar with a project that you know where the source is, whereas someone who's new to the project is not going to be quite so sure. Yeah, the bad. Writing new code in a short space of time means you are going to probably make some poor design decisions at some point, and they can have time-consuming knock-on effects down the line. You might have to rewrite code. You're probably going to have to rewrite code. You just want to try and avoid that, but it's going to happen. It's one of those things you need to like make your peace with. You're not always going to write the best code. You may not even always write good code, but as long as you're willing to take the bad code you wrote, look at it and go, I wrote bad code, kick it to the curb, replace it, fix it, you're good. Yeah, and obviously because you're writing new code rather than maintaining old code, you're more likely to reinvent the wheel, which is one of those negatives that you try to avoid, but it happens. Yeah, this is actually a slight reiteration on that previous point. Yeah, small team plus large workload. You're gonna write some code quickly rather than properly. On the plus side, you hopefully get to rewrite it. Yeah, that cartoon is less applicable when you're working in a small team, because you probably did write that crappy code. Ideally, you get to the point where your company is big enough where you can say, I did not write that crappy code. And then obviously using the latest, greatest features, tools, etc. does, sometimes you're going to encounter bugs, and sometimes they're going to be hard, they're going to be like showstoppers. But, it's ideally you're using open source stuff. Either you can fix it yourself, or you can go onto GitHub. You can, plug an issue, and, I think even if you don't have time to contribute to open source in general, even just filing an issue on GitHub is a contribution which someone somewhere will appreciate, because they will end up on GitHub with the same issue, and they'll go, someone else had this problem. Maybe, the person who wrote the project goes, yes, we're going to fix that. No, you're doing it wrong, etc. Yeah, I'm almost at the end. Problematic frameworks. Ginger 2, to be fair, nothing wrong with it, except, it gives you the opportunity to do server-side template inheritance, which it's really useful, but it also can get you up the creek without a paddle when you end up with templates inheriting from templates, which include other templates, etc. You kind of get the idea. It's obviously one of those things where, great power, great responsibility, yada, yada, yada. Django South, extremely useful. The migrations are great. You obviously need a migration strategy, for an application which is going to be used in the real world. But at the same time, when you have multiple team members and you've got multiple VCS feature branches with multiple migrations which potentially conflict, you have to realize that this is going to happen and have an idea of how to solve it. Yeah. Tasty Pie, it's probably not as bad as you've heard. I used to think it was the devil, but then I actually got down and read beyond the documentation and realized that actually Tasty Pie, it's not the best, but if you read the documentation, you realize how you're supposed to use it, you can use it with a sort of minimal amount of teething. And then, yeah, I think the only other main bad thing is abandoned/forked libraries that are still on PyPy, the Python Package Index. Obviously, the one which probably everyone knows about is pill versus pillow. Pillow has superseded pill, but if you go looking, you're probably going to find pill. And if you don't know, you're going to use pill. And you don't really want to use pill. It's not exactly maintained anymore. And I think it's a bit of a pity that these sort of dead projects are still prominent on PyPy. They should maybe sort of drop down in terms of importance. Yeah, as I said, it's a bit more common than you like, but you just have to be really careful when you pick a library, actually check and see, okay, is this mature? If it's not mature, has it been updated in the last 6 months? If it's not, maybe you want to look somewhere else. And the ugly, this is the end. This is pretty much the last slide. Nothing really. I don't think there's anything particularly ugly about Python. Personally, I'd loved if there were proper anonymous functions, but I understand there are reasons why. And it's not a showstopper because of the fact that we have actual first-class functions. The only other thing is that it's actually quite hard to find. I use the word exceptional here, but what I really mean is people who fit into the sort of mindset of a startup, which is, in a startup, you really have to be willing. And it's where the DevOps movement has come from. You need to be willing to do everything. You can't say, I'm only going to work on the back end, front end, whatever. You have to be able to, do it all and be willing to do it all and happy to do it all. And in this context, it's quite hard to find people in South Africa because the Python community here is still quite small. So obviously, I think, we can all do our best to try and grow it. And then, just a little dig at Amazon. Gobbling up all the developers. I think probably everyone has probably gotten the occasional, hey, come work for Amazon. Nudge, nudge, nudge. And that's it. Don't know if anyone has any questions or if we even have time.
Maybe, shall we thank our speaker first?
I really thought that I was going to finish this ahead of time because I only had 13, 14 slides. Oh.
Okay. Does anyone have any questions? We have time for one question while the next speaker sets up. Would you mind sitting down while we... Is that a hand over there? No? So, you said you work in a team of 1 to 2.
Currently, yes. We've actually just picked up another developer, really cool guy from Pretoria. He's going to be moving down to Cape Town in the near future. But we're definitely looking to get more people because, more people do tend to make life easier. There is a hard limit to how much 1 or 2 people can get done.
So is your new person already a Python person, or is he someone you're going to have to convince?
Oh no, he's actually a lecturer at the University of Pretoria. But he's pretty awesome. He's definitely, he's one of those, right fits where, we were like, okay, this is the one.
Okay. Excellent.
But we could always use more people like that.
Cool. Right, thank you.
Thanks.